Okay, here we go. This should be the last actual class and homework. The rest is test and review. I'll just say the one class that you're missing that we're cutting short here is 12.4, and that's surface area or total area and volume of a sphere. And those are definitely some formulas you should be familiar with as you move forward. I encourage you to research those on your own. Okay, last homework of the year. Here we go. Cylinders and cones. Now it's two different shapes. So we're going to get a total of four formulas. For each shape, we're going to get total area and volume. All right, reminder, these are all the shapes. And like I said, we're going to have covered everything except for the sphere there at the very end. So the last few classes, that might have been the most challenging one right there, the pyramid. But for every single shape, we've done total area and volume. And one of the intermediary steps to total area was lateral area, and that's just the area of the sides. Remember, total area is the sides plus the bottom. And volume is there's just one formula for that. Um, for surface area or total area, basically, it's adding up the surfaces of all the sides of the shape. So the bottom plus the sides. The sides are called the lateral area. The bottom is called the base. So different day, same drill, but for two shapes this time. So total area or surface area and volume. I will do that for cylinders and cones. All right, so think about this. Take a cylinder. We're familiar with cylinders. So what is a cylinder? So a cylinder is made up of two congruent circles that are parallel to each other, and then connecting those two congruent parallel circles is, well, it sure looks like a rectangle that has been turned into a circle, and that's what it is, and that's what makes a cylinder. So a cylinder is a 3D object with two congruent circular bases and a curved surface that's actually a rectangle that joins those two circles. All right, so the parts of the cylinder, this should be old hat. We did this in 7th and 8th grade. We got the bases. Those are the two congruent circles. They are parallel. We have the side, which is curved. We call that lateral area, just as we did for all the other shapes. And then lastly, the perpendicular distance between the two circles is called the height. You're probably wondering, why don't we call that the altitude? Remember, altitude and height are interchangeable terms, and it is customary for cylinders to have heights. All right, so it turns out, as with all the other shapes, there's two types. There is the right cylinder, and there is the oblique cylinder. And the only difference is that the height for a right cylinder goes to the center of the two circles, where the height of the oblique one does not go to the center of the bases. It's still measured the same thing. The height is the distance between the two circles. And I stated this before at the start of the chapter, we will only be doing right 3D objects, no oblique ones. No oblique objects, if you take higher level math, you will get those. But for this high school geometry, we only do right 3D shapes. All right, so now let's get those two formulas, one for volume and one for total area. So think about this. So if we think about the construction, it's there in that picture right there. Cylinder is made up of two circles and a curved rectangular shape that forms the sides of the cylinders. So that what I'm showing right there is the rectangular side, or the lateral area. Well, since it's a rectangle, we know the formula for area of a rectangle, base times height. But now let's think about where the base and the height of that rectangle on the left comes from the cylinder on the right there. So if I think about the base, that dimension right there, and I curve that back to where it's supposed to go, well, that ends up being the circumference, right? This part, the base right there ends up being the circumference of one of the bases, and that's its dimensions. It's the same thing. These two dotted red lines end up having the same distance. So therefore, the rectangle's base on the left is the circumference of the base of the circle. Well, what about the other dimension, right? So the other dimension is the height, and the height is the distance between the two circles. Well, that's the height of the height, if you want to think that length and width, that's the width of the rectangle right there. We'll call it the height. So therefore, the area of the rectangle, which would be the lateral area of the cylinder, is circumference times height. Well, that's pretty convenient, right? We just said that the height is the height, and that's the circumference. So the lateral area is circumference times height, and we have a formula for circumference from the previous chapter. If you remember, lateral area is base times height, but the base is the circumference, little b is the circumference, and circumference is 2 pi r. So if we combine that with that h, we get 2 pi r h. So this is theorem 12.5. This isn't total area, this is just lateral area. So lateral area of a cylinder is 2 pi r h. Write that one down. Okay, cool. So now we have lateral area. Once again, our book doesn't give us a formula for total area, but think about this. If lateral area is just the blue part, we're just missing the two bases, and the two bases are circles, and each circle's area is pi r squared, and I have two of them, so that would be 2 pi r squared. So total area is lateral area plus base. We just said that lateral area is 2 pi r h, and base is a circle, pi r squared, and there's two of them, so that would be 2 pi r squared. Add those together, and we get to total area. I would write that one down. Just a reminder, it's not in the book. They expect you to be able to figure this out all by yourself. Total area of a cylinder is 2 pi r h plus 2 pi r squared. And if you look at that formula, we only need two measurements. We just need the radius and the height. Okay, so this one is not a theorem, right? And if you didn't write down the previous slide, I make a big point class saying, all right, make sure you write this down. So this is exactly the same as that right here, just in a more formal form. All right, quick side note, and you had a problem with this on the last test. The questions for homework and the upcoming test will say either what is the answer or what is the answer in terms of pi. So remember, if it says in terms of pi, we're not multiplying anything times pi. We're just leaving pi as pi. Don't multiply by pi is what I'm saying. 2 pi r, we're just going to multiply 2 times radius and leave it alone. Attach a pi to it, and there's your answer. So here's what I mean by that. Calculate the total area of the cylinder in terms of pi. So there's the cylinder. Looks like it has a height of 4 and a radius of 5. So total area was 2 pi r h plus 2 pi r squared, and the radius and the height. And look, they gave me both of those measurements. But it says leave it in terms of pi. So that symbol pi just stays as a symbol pi. We don't multiply by 3.14. So let's see, 2 times 5 times 4, that would be 40. 2 times 5 squared would be 2 times 25, which is 50. So I get 40 pi plus 50 pi, which would be 90 pi. And we do not multiply the 90 times 3.14. We just leave it that, and we attach the units. We're doing area, so that would be centimeters squared. So that's an answer in terms of pi. If it did not say that, we take that 90 and multiply it by 3.14, use the pi key on the calculator. All right, next idea. This is going pretty quickly, volume. If you think about this as pizzas stacked one on top of each other, or pepperoni slices stacked on one on top of each other, well, each pepperoni or pizza slice, the area would be pi r squared, and stacked all together, there would be h of them. Well, then it's pi r squared times h, and that's the volume formula. So once again, I only need two things, the radius and the height. So both for total area and for volume, I still only need two things, radius and height. Be ready for them to give you diameter at some point. Remember, if they give you diameter, don't get to an answer and then divide by 2. Make sure you're plugging in a radius. So if they give you the diameter, divide the diameter first before you plug anything into a formula, because you only need to plug, or you're supposed to only plug in radius into the formula. So there's the final formula for cylinders, and it's for volume. Okay. So calculate the volume of, hey, it's the same cylinder, by the way, and we only need two things, the radius and the height, and they gave us both of them. Radius is 5, the height is 4, plug those in. It says leave it in terms of pi, so we're not going to multiply pi times anything. 5 squared is 25, and 25 times 4 is 100. So 100 pi cubic centimeters, because remember now we're doing volume, and volume is measured in cubic units. If it didn't have that leaving in terms of pi, we'd multiply 3.14 times 100 and get 314 cubic centimeters. All right. Last shape of the year. Here we go. Cones. Cones are a little bit harder to visualize, right? So a cone is a 3D object with a circular base, only has one. Cylinders have two. Cones only have one base. And a curved surface that curves to a point. It's not a pyramid, it's cone, but it has a similar, feeling of a pyramid. Pyramid has sides that are rectangles. Cones have curved sides. And it's that curved side that's hard to imagine flattened out. It's easy to visualize in your head what a cylinder looks like laid flat, but cones are a little bit more challenging. So let's go over parts of the cone first. Well, let's see. We got a base. That's a circle. We got the side area. We'll call that the lateral area, just as we did for all the other shapes. We got the distance between the base and the vertex at the top. We're going to call that the height. Height and altitude are interchangeable. And lastly, along the outside of the cone, if you went from bottom to top, staying on the outside, that's going to be called the slant height. Okay. Hey, you could probably teach this slide now. There's two types, right? There is the regular one, or the right one, sorry, the right cone and oblique cone. The only difference is that a right cone, the height goes from the center of the base to the vertex, where a oblique cone, the height is off to the side a little bit. All right, we will only get formulas for right cones. Now comes the challenging part to try to visualize, not the base is just a circle, but visualize what is that shape there of the side, the lateral areas laid flat. You may have to play this part of the video a couple times to completely catch on. So I tried to draw it for you right there. So the blue is the lateral area, the base is the orange or brown area right there. So I'm going to try to get a formula from this. All right, you see the little L there? That's your slant height. And it sure looks like that the lateral side of it is bigger than the base itself, just by casual observation. All right. Well, if we consider the blue as being a sector, right? The base is easy. It's just pi r squared. But if we consider the blue there, the little Pac-Man looking thing right there, as being a sector, luckily we have a formula for sector from 2 chapters ago. Remember, this is the formula for sector area. So sector area is x over 360 times pi r squared. Well, our radius on that blue Pac-Man thing is L, so that changed an R to an L. And remember that X is the angle that's formed, the central angle. And we're not talking about the central angle there for the white portion. We're talking about for the blue portion. Okay. Well, cool. Though that would give me the sector area right there. And then simply, well, that would be the lateral area. So let's see, X over 360. We got to do something with that. So let's think about this. So X over 360, right? Well, that would be an arc length right there. And we know a formula for arc length. Arc length would be, well, whatever that arc length is, divided by its circumference. That would be the same percentage as the angle to 360. So in other words, instead of x over 360, I could do the arc length of the major arc, ABC, over the entire circle. I didn't draw the entire circle in red there. I just drew a portion of it. So that would be equal to the same percentage as x over 360 from our original sector area formula. So we're doing a little substitution right there, arc length of ABC over circumference. Why? Because I can calculate both of those. I don't know what that angle is right there, but I do know what the arc length and the circumference, because I got formulas for both of those. The formula for circumference, once again, let's see, is 2 pi r, where r is the radius, and our radius is L. Okay. If we think about that green circle right there, right, that would be the entire circumference of the blue thing, right? Because think about it wrapped back around the cone. The red thing would be the length of the green thing. So that circumference would be 2 pi r, right? So I've got a 2 pi r over a 2 pi l, with the 2 and the pi's would cancel, and I would be left with r pi l squared over l. But now I got an L on the bottom and 2 L's on the top. Cancel that out, and the L on the bottom cancels. I'm left with, and I'll put the pi first, pi RL. So that was a long way to prove that one, but all I've proven is what is the area of the blue Pac-Man. In other words, what's the lateral area? So the lateral area, this is theorem 12.7, says it's equal to pi RL. So a long way to get to that proof, but we proved it. And once again, I just need 2 things. I need the radius and the slant height. The but here is that, once again, they don't give us total area. So let's see. If the lateral area, which is the side, is pi RL, all I need to do is add the base area. And the base is a circle, that's pi r squared. So write this one down, right? Another theorem that's not a theorem. total area is equal to pi RL plus pi R squared. Okay, there we go. One more formula and we're done. Let's do a quick practice problem right here. It says calculate the surface area of the cone in terms of pi. Well, let's see. We just wrote down surface area is pi RL plus pi R squared. So I need radius and slant height. And notice I got a radius of 3. I got a height of 6, but no slant height. Luckily for us, hopefully you see it. There's a right triangle right there. I got 2 measurements. It would be easy to calculate the slant height L by using Pythagorean theorem. 6 squared plus 3 squared is equal to L squared. So 36 plus 9 is 45. And the square root of 45 would be 9 times 5. Square root of 9 is 3, so 3 root 5. So there's my L to throw into my formula right there. I already know the radius is 3, right? Slant height was 3 root 5. So see, 3 times 3 is 9, so we get 9 root 5 plus 9 pi. It says leave it in terms of pi, and that's all we can do. We can't do anything because pi is 3.14, and it says leave the answer in terms of pi. The previous one, we got a nice answer. What was it, 40 pi plus 50 pi? You can add those together. But this one has a root 5 attached to that one on the left, so we can't add that to 9 pi. Okay, that's how that one's done. Last formula of the year. Here we go.
If it is 1/3 of the volume. So let's fill the cone up the first time.
I've got a cone filling up a cylinder.
And it is a cylinder.
Notice the cone and the cylinder have the same base. It's the same circle. So he filled it up once. Filled up twice.
A third time.
There you go. So what would be the volume of one cylinder, one cone? It would be a third of the cylinder. And we already know the formula from the previous one for the volume of a cylinder, which was pi r squared h. So all we got to do now is take pi r squared h and divide by 3. And there's our last formula of the year. Remember, they got the formula for total area and volume of a sphere as well, too. And hopefully you looked those up for your own knowledge. All right, let's do one problem, call it a year. Let's see, calculate the volume of cone in terms of pi. Once again, formula for volume is pi r squared h divided by 3. I don't need the slant height for that. I just need the radius, which is 3, and the height is 6. This is just plug those in. 3 squared is 9. 9 divided by 3 is 3, and 3 times 6 is 18. And the pi stays pi because it says leave it in terms of pi. Notice I put cubic units right there. Don't forget your units. All right, as always, we get a table. Enjoy the table. You should be a pro at it by now. And Chris, that does it for today and for the year. All right, we're still going to do a review. I will send you a review of the test, no video. And then I'll send you the test on Thursday morning, same as the last time. If you do have any questions about the review packet, make sure you email me so we have time that maybe we could do a Zoom meeting or something like that. If not, then we'll take the test on Thursday. On Friday, I will send you a review packet number 1 for the semester final. And then on Monday, I'll send you review packet number 2 for the semester final. It'll just be a bunch of multiple choice questions. The final test will look exactly like that. Take those 2 review packets, and that will prepare you for the final. I'll send you the final on Tuesday morning, bright and early. Get that done. Take your pictures up, send me in, and we are done for the year when you get that turned in. If you have any problems, send me an email. More than happy to help you. Have a great day.